And here, last part of lesson 9.7, which also means the last part of chapter 9. Woo! What we're going to be doing next is we're going to be writing polar equations for a specific conic. And in order to do this, we have to follow the general form of these equations, where you have r equals EP over 1 plus e sine of theta, or you have r equals EP over 1 minus e sine of theta. So if we look at these two, whoops, didn't mean to do that. If we look at these two lines up here, or equations here at the top, well, the big difference between them, in fact, the only difference, is your plus and your minus. What that means is if you have a plus or a minus, then that means if it's a positive, you have a horizontal directrix above the pole. Well, the pole is what we call your origin. So if we were to have an a little graph, looks like this, and you have to remember that your focus of your graph would be here at your origin, and your graph would look something like this here, and then you'd have a directrix, and your directrix would be going a horizontal line above your pole, so it's above the origin. Well, in this case, you would have a y equals some positive value, so say y equals positive 4. In the second equation, we have r equals EP over 1 minus e sine of theta. Well, here you would have a graph where you have a value, your focus at the pole, and your graph would be going up in this case, and your directrix would now be below the pole, which means you would have, go along here, this would be y equals some negative value, like a negative 5. Okay, that negative right here determines your negative in front of your e sine of theta. The same thing happens if you have a graph where if you have a vertical directrix to the right of the pole, so that means you'd have x equals some positive value. That gives you your plus sign in front of your cosine. And if you have a vertical directrix to the left of the pole, that would give you your minus. Now, how can you tell the difference between sines and cosines? Well, a sine is when you have a horizontal directrix, or that means when you have your directrix, means the same thing as when your directrix is a y equals some number. So this is going to be some positive value. When you have a negative and a sine, that means you're going to have y equals some negative value. So keeping that in mind, if you have a cosine and you have a plus, that means you're going to have x equal to some positive number. If you have a cosine and a negative, that means your directrix is going to be like a negative 2. So let's look at our last example here. We're going to find the polar equation of a conic. And when you find the polar equation of your parabola, whose focus is at the pole and whose directrix is the line x equals negative 2. So like we just said, if you have x equals negative 2, your equation is going to be r equals e times p, all over you have a 1. Now is this going to be a minus or plus? Well, if you look at your negative here, that means you're going to have a minus e, and since you have an x, that means you will have cosine of theta, not the sine of theta. So what we have to do is just plug in some values. Well, one of our values we need to know is our e. Well, since we have a parabola, remember we talked way back in the beginning of this section, your e is always equal to 1. If you were given a hyperbola, then it will actually give you what your e value is. So you would say like e is like a 3 or a 4 or something. If you have an ellipse, remember your e is between 0 and 1, so you might have a 2/3. So we have e equals 1. Well, we also need to know p. Back here, we found out that p is the distance between the pole and the directrix. So if we have the distance between the pole and the directrix, then we have p is going to be equal to, your pole is at your origin. Well, the distance from the pole to x equals negative 2 is just 2. So we're going to, whoops, I don't know what happened there. So we're going to plug in for your equation r equals e, which is 1, times your p, which is 2, all over 1 minus 1 cosine of theta, and we can clean this up a little bit and just say we have the equation r equals 2 over 1 minus cosine theta. And that is the equation for a parabola that has its focus at the pole and has a directrix of x equals -2. So let's do the same thing down here for b. Here we have, once again, we have another parabola. So if we have another parabola, we know that that tells us our e value is just 1. We need to find our p value. Well, p is going to be equal to, if we have y equals 3, the distance from the pole to 3 is just 3. Our equation now, we know we're going to have an EP on top. We know we're going to have a 1 on the bottom. And it's going to be a positive or negative. Well, your 3 is a positive 3. So we're going to have a plus. We're going to have an E here. And we have a Y, which doesn't mean cosine. Y means sine. So you're going to have a Y, or you're going to have a sine of theta. So let's plug in our values. R equals E, which is a 1 times 3 all over 1 plus the sine of theta. Now, in some of your problems in your homework, you're going to end up with some fractions. So if, for instance, you get something where you have R equals a 2/3 minus like a 1, or with a 1 minus, it'd be like a, I don't know, 2/5. That's not going to work out. Like a, I'll say a 2/9 cosine of theta. Well, you can't leave these as fractions, so what you're going to have to do is multiply top and bottom by a common denominator. Your common denominator between a 3 and a 9 would be a 9, so you have to multiply everything by 9, so you'd end up get the equation on top. R equals a 6 over 9 minus 2 cosine theta. Notice how you don't have any fractions here, but this is what your equation would be. So I hope that helps clarify a few things in 9.7. Once again, this is the last section of 9.7 conics. And Klein out.